Our fifth sem physics paper is Physical Optics and Modern Optics. Optics, what is optics? Optics is the branch of physics that studies the behavior and properties of light, including its interactions with the matter and the construction of instruments that use or detect optics. Usually describes the behavior of visible, ultraviolet and infrared light. Now, in this, our first chapter is Fermat's principle. The Fermat's principle is a remarkable and important principle in optics. Fermat's principle. Fermat's principle. This principle explains why light propagates along straight lines and the laws of reflection and refraction. Before we discuss the Fermat's principle, we must know the optical path. Optical path. When a light travels in a medium, the distance traveled by a light is s, and the velocity of light is v in a medium, then time is t. S is the distance traveled by light and the v is the velocity of light in that medium and t is the time. So we can write S is equal to Vt. From the definition of refractive index, we know mu is equal to C by V. C is the velocity of light in vacuum, then V is the velocity of light in medium. So from this equation, we can write V is equal to C by mu. This is equation 1, this is equation 2. Equation 2 is substituted in equation 1. We get S is equal to C by mu into T, or mu S is equal to Ct. For a given time, RH is constant. Hence, LH is mu S is also a constant. This product mu S is called optical path. That is, optical path is defined as the product of the geometrical distance and the refractive index of that medium. S is the geometrical distance, mu is the refractive index of that medium. The product of mu and S is called optical path. Then note that if a ray travels a distance s in a medium of refractive index mu, the optical path is equal to mu s. In a given time, light travels the same optical path in different medium. In a given time, light travels the same optical path length in different medium. Suppose light travels a distance s1 in a medium of refractive index mu1 and the distance s2 in a medium of refractive index mu2 at a given time t, mu1 s1 is equal to mu2 s2. That is, when a given time light travels the same optical path length in different medium. That is, mu1 s1 is equal to mu2 s2. When a ray travels distance s1, s2, s3, etc. in a medium of refractive index mu1, mu2, mu3, etc. Then the total optical path is equal to mu1 s1 plus mu2 s2 plus etc. That is summation I equal to 1 to n mu I s I. For a medium of continuously varying optical density, optical path of a ray going from P to Q is given by S is equal to P to Q mu ds. That is, in a continuous medium, the summation is replaced by integral p to q mu ds. For a continuous medium, the total optical path is p to q mu ds. Thank you.